Hello participants. In this lecture, I will discuss descriptive statistics, which is the remaining part of the previous lecture. I have started descriptive statistics in last class, and the remaining part will be discussed in current lecture. So, what we have discussed in last class, I introduced you statistics. Then we discuss descriptive statistics as well, and the remaining part will be discussed in current lecture. We have seen types of data like qualitative data and quantitative data. Then how can we describe the data as well, right? So describing data we have seen. So these concepts had been discussed in last class. In a current lecture, I will discuss measures of centrality and measures of spread. So what is measures of centrality and spread? A statistic is any numerical property of the sample of a population which is used to estimate the population. So we have seen what is population and sample. So we cannot find the value for whole population, because the value is the instances are very large. So what we actually do, we take sample from that population and we'll find out certain statistics on that sample, and in that case we'll estimate the population. Following can be computed for quantitative data, measures of centrality, mean, median, mode, and measures of spread, so range, variance, standard deviation. That we'll discuss in today's lecture. So what is measures of centrality? So we are having mean, median, mode as far as measures of centrality is concerned. So mean is actually average value. And how we can calculate average value? Sum all the numbers and divide it by the number of instances, right? So in this way you can calculate the average value. Suppose we are having 10 different data, 10 different ages, suppose. So you will calculate, or you will take sum of all and will divide it by 10. So in this way you can calculate the average age. And what is median? So mid value in sorted list. First you need to sort the list, and then if total number of elements are even, then average of values present at two mid locations, right? If your total number of elements is odd, then you can find the mid element directly, right? And mode is most frequent occurring values. We are having single mode and multiple modes. Suppose there is a single element which is occurring again and again, right? There is a single value which is having multiple occurrences. So that is single mode. Suppose if there are more than one element which are occurring again and again, so that is multiple modes. Consider the sample. So like 23, 24. So you are having this sample, and you need to find out mean, median, mode, and accidentally it is already sorted. So you need not to sort it. So first you need to find out the mean. So what would the mean? The number of elements in this case is 1, 2, 3, 12 elements are there in this particular list. So mean would be adds all and then divided by 12. What is the median here? Since you are having even numbers, so you need to you need to find out the sum of two elements that is there in between. Like in this case, let me come to this state. So you are having this value 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. So this is the mid element. So this one is the median, right? Here we are having 11 elements. Sorry, not the 12 elements. The number of elements are 11. So mean would be sum all and then divided by 11. Median is this one 28, and mode is 27 is the mode. Since 27 is having two occurrences in this list, right? So we have seen how to calculate mean, median and mode. Suppose there is one more element 38, right? So what would be the median in this case? So the median would be you need to sum the two values, right? And the two values would be, so you need to find out the sum 28 plus 30 and then divided by 2. So this would be median, right? And again the mode would remain same. How much sensitive towards outliers? I have already discussed the outlier is a value which is not in the range, right? Whether it is very high or it is very low, right? So since mean is the center of gravity, and if you would sum up the sum of deviations of all points from the mean, then you will find out 0, right? So if you need to find out the deviations of each and every element from the mean. So how it would be 0? Since suppose you are having 5 different points, 5 different element in your list, x1, x2, x3, x4, x5. So how this would be 0? Like in this case, so since you need to find out the summation of differences of each element with the mean. So I would write it here, x1 minus x bar, then summation of x2 minus x bar, then plus x3 minus x bar, plus x4 minus x bar, plus x5 minus x bar, right? And if I will sum it, so here you will get x1 plus x2 so on x5, and here you will have 5 into x bar, since x bar came here 5 times. So this will be, again this will be x1 plus x2 and so on x5, and this will be, since x bar is actually summation of all divided by 5, right? x1 plus x2 and so on x5 divided by 5. So it will be cancelled out, and then you will get same value before the minus and after the minus operator. So you will get 0 here. So in this case, when you will sum the deviations of all the points from the mean, you will get the 0. So outlier is how actually our mean, median and mode is sensitive towards outliers, right? So outlier is any point which is far off from the other values in the data, right? Far off, it means either it is very low or very high. Mean is sensitive to outliers. Let me erase all these. So how mean is, I'm saying that mean is sensitive to outlier, and you can observe it, right? Because suppose you are having, you have calculated mean, and suddenly a data came which is very high, right? So again your mean will get changed, right? Because you are summing all the values and dividing by n. But median and mode are not sensitive to outliers, because median is the mid value, right? And suppose you are the last value which is there in the list, which is very high, so it is not going to change the median. And mode as well, right? Because your mode is the a value which has come to the list most time, right? So occurrences of that element, the element which has highest occurrences in the list, so that is the mode. So again the outlier will not affect the median and mode, but mean is sensitive to outliers. Now we'll see how to measure a spread. And why there is a need of actually measuring the spread? So there are two sample here. Sample 1 which is having this value. So if you will calculate mean, then it would be 29, and again median will also be 29. Why so? Because if you will calculate these two, since this list is having 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 10 elements are there. So this is the mid elements. So 28 plus 32 divided by 2, right? So you will get 29. So mean and median both are same. And if you will observe this list, you will observe there is a low variability in this sample. It means there is a difference of 1, and in some cases there is a difference of 2, like 23 plus 20 plus 1 is 24. Then there is a difference of 2 in this case, similarly 2. So variance is, variability is very low. Now consider the next list. Again the mean and median is same, but the variability is very high. You can observe it, right? There is a difference of 4 here, there is a difference of 5 here, right? But the mean and median is same. So measures of centrality don't tell us anything about the spread and variability in the data. How your data is being spread here, how your data is data is scattered. So it doesn't tell about the spread and variability of your data. So that's why we need to measure spread. So measure of spread, there is a concept that is called range. Through range we can measure the spread. So how to calculate the range? Just maximum value minus minimum value, which is 13 in this case in very first list. And again the range in the second case, the range is 35. So after seeing these two values, so I can observe that in this case, in the very first list, spread is very low. As far as this sample is concerned, the second sample is concerned, the spread is very high, right? So range tells us that second sample has more variability and spread as compared to first one. Now consider this sample. Here you will observe range is 77, high maximum minus minimum value. And you will observe it that most of the value is close to 28, right? You can see here most of the value is close to 28. But due to outlier, in this case 100, the range is exaggerated, right? Because of actually outlier, since it is becoming a maximum value, right? In this case, range will also be exaggerated. So like mean, range is also very sensitive to outliers. It is very important. So we have seen mean is sensitive to outliers, but median and mode is not sensitive to outliers. And as far as range is concerned, range is also very sensitive to outliers. Now we will discuss variance. So how different are the values in the data from the typical value mean in the data? So it means it says how each and every value is varying from the mean value, and how it is different from the mean. So one solution is compute the sum or average of deviation of all points from the mean. So that is the one solution, but we have seen that it is actually 0, right? So sum of deviation doesn't talk about the spread of the data since the value is 0. So preferred solution is take square of all these and divide by number of elements. So measure of spread, variance of the sample, right, is 1 divided by n minus 1, and then summation of this value xi minus x bar, where x bar is mean, right? This one is the mean. And standard deviation is square root of s square is square root of variance. And variance is measure of consistency. Low variance shows more consistent data. It is very important. Low variance shows more consistent data. It means the data is very much near to the mean, right? If the variance is very high, it means the data is variance is very high. If your variance is very high, it means data is not so much consistent in your list. So the primary objective of, like we can take an example, the primary objective of manufacturing industries is to ensure that there is a little variance in their products. Suppose they are, making different shirts, right? There is a company who is manufacturing shirts, and they want to have variance 0 because they do not want any of the product length, shirt's length, to be more than what they have decided, right? So length of sleeve, in this case, the desirable variance is 0. Similarly, if a company is manufacturing a bag, so size of all the bags in each category, in this case, the variance should be 0, right? So if the variance would not be 0, it means their size of bag would vary in the same category, right? Similarly, if in case of shirt, if variance is not 0, it means in the same lane, suppose it is XL or double XL, in same XL, the length of sleeve would vary. So that is not the ideal condition. So that's why it is very important terminology, variance and standard deviation. So I've given one exercise here, exercise on variance and standard deviation. So you have been given, suppose a sample of data is 1, 2, 3, 4, 5, 6. So I have given a very small list and very simple exercise. So you need to calculate variance and standard deviation. So how we will calculate variance? First, so variance is first we will calculate mean, right? So mean is 1 plus 2 plus 3 divided by 6, 3.5, and variance is xi minus x bar summation I is equal to 1 to n, right, and divided by 1 n minus 1. So this is the value. So I am calculating this value, 1 minus 3.5 plus 2 minus 3.5 and so on. So in this way you will get 3.5, right? And standard deviation is square root of 3.5, which is 1.87. Let me erase this one also. I'm just erasing this one, and yes. And coming to next slide. Now there is one more type of diagram that is called box and whisker plot, and this will again come under descriptive statistics, and through which using the box and whisker plots we can find out what is the minimum value and maximum, median, first quartile, third quartile. So this value can be observed by looking on a single plot, that is box and whisker plots. So a box and whisker plot displays the 5-number summary of a set of data. The 5-number summary is the minimum, first lower, or you could say first or lower quartile, median, third or upper quartile, and maximum. So these are 5 different values. And so very first one is minimum. So minimum is the lowest data point in the data set, excluding any outlier. Similarly, maximum is the highest data point in the data set, excluding any outliers. And what is median here? So we have seen how to calculate median. So median is the middle value in the data set. First quartile, it means it is also known as lower quartile. It is the median of the lower half of the data set. So which Q1 is the median of the lower half of the data set. And the third quartile, that is Q3, or you could say 75th percentile, also known as the upper quartile. It is the median of the upper half of the data set. Median of the upper half of the data set. That is actual median and maximum, right? So this is the third quartile. In a box plot, how to then suppose you are having this value minimum, maximum, first quartile, third quartile, and median. So how can we draw box and whisker plot? So in a box plot, we draw a box from the first quartile to the third quartile. First, you need to draw a box from first quartile to the third quartile. Then a vertical line goes through the box at the median. So you need to draw this one. The whisker go from each quartile to the minimum or the maximum. It means the first quartile to the minimum and third quartile to the maximum. A whisker would be will go from this side, both the side, from first quartile to minimum and third quartile to maximum. We can use this Python function to draw box plot. We'll see how can we use in later on classes. So box plots are used to visualize spread, median, and outliers, right? So you can see here, this one is the minimum value and lower quartile. Then there is a median and upper quartile. This is the maximum value. So a whisker goes from Q1 to minimum and Q3 to maximum. And then we can calculate interquartile range, Q3 minus Q1. So this would be the interquartile range. If you want to find out whether there is any outlier, suppose there is an outlier, there is a data here, right? So how can we calculate outlier? If any value is less than Q1 minus 1.5 times interquartile range, then those value will be called outliers. So like in this case, if any value which is less than Q1 minus 1.5 into IQR, so that would be the outlier. Similarly, if any value which is greater than Q3 plus 1.5 into IQR, so that would be the outlier. So in this way, I can calculate the outlier. And once you will draw the box plot using any Python function, and if you are using like matplotlib, so automatically you will see if your data is having any outlier. So you will observe certain data points here and there. So these data points are actually outliers. Now there is exercise. How can we draw a box plot? So to draw a box plot, you need to first find out 5 different parameters. And what are those parameters? You need to find out minimum, first quartile, median, third quartile, and maximum. So you have to find out these values. So first one is minimum, right? Minimum here in this case, since this data is already sorted, so minimum is not sorted, sorry. This data is not sorted. So the minimum value is 25 and maximum value is 38, right? And you need to find out the median. So what I will do for finding the median, I need to sort this list, right? So the list would be 25, then 28, 29, 29, 30, 35, and in this way. So the middle element will be the median. So like in this case, here is the solution. So for in step 1, first I have ordered the data from smallest to largest, and we have calculated the median value. And what is the median value? Since there are 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Since there are 10 elements, so even number of elements are there. So I need to find out 2 middle element, right? So these 2 middle element, 30 plus 35. So it will give you the median value is 32. I'm considering the integer value. So 32 will be your median, and sorry, not 32, 35. Just a minute. Let me erase this one. So and after the I need to find out the median after sorting. So the median would be sum of these number divided by 2, right? So average of these two values. So the median is 32. It's okay. Now the you need to find out the first quartile. So the first quartile is the median of the data points to the left of the median. So what are the left element left of the median? So median is 32. So the value will be 25, 28, 29, again 29, and then 30, right? So these are elements left to the left to the median. Now calculate median of this value. Calculate median of this value. So what would be the median? So median is 29. So this is the first quartile, right? And then find out third quartile. So again, I will find out, to find out the third quartile, you need to look on the data points to the right of the median. And what are the data points which are right to the median is? So data point would be 35, 34, then 35, 35, 37, and 38. So to find out the median of this sorted list, so this is the median 35. So I will get Q3 as 35. So in this way I can calculate the whole data. So complete the 5 numbers vary. So the minimum is the smallest data point, which is 25. The maximum is the largest data point, which is 38, that we have seen. So this one is the 5 number summary. If I need to calculate, calculate interquartile range. So what would be the interquartile range? So interquartile range is Q3 minus Q1, third quartile to minus first quartile. So this one is the first quartile. So this one is the minimum, first quartile, median. This is third quartile, and this is maximum. So this is Q3 and Q1. So Q3 minus Q1, 35 minus 29. So you will get 6. So interquartile range is 6. So in this way I can draw the whole box plot, right? And here you will find the minimum which is 25. Here you will get 29, and here you are having 32, and this is 35, and finally you will get 38. And this is the interquartile range is 6, right? In this way I can draw the whole box plot. Let me erase this one. So it is very important to draw a box plot. So by looking on box plot, I can at once I can find out minimum, maximum, median, first quartile, and third quartile, and outliers. To summarize this lecture, what we have seen in current lecture. So we have seen measures of centrality. How can we measure centrality? So there are different parameters like mean, median, mode, through which we can measure the centrality. And we have already seen measures of spread, variance, and standard deviation. And we have also seen the effect of outliers on centrality and spread, right? So on centrality, if I am talking about centrality, so mean has so much effect because of outliers. Similarly, range will also get affected because of outliers. And variance, and what about variance and standard deviation? What do you think, that will outlier will affect variance and standard deviation or not? So yes, it will affect, because as far as variance and standard deviation is concerned, So the main component is finding mean, right? Since mean is affected by the outliers, so variance and standard deviation will also be affected by the outliers. So this is all about today's lecture. Thank you for joining the lecture. I'm stopping here and we'll meet again in next lecture.